have a look on the syllabus of this subject. Is it visible?
Yes, ma'am.
Okay. There are actually 4 modules. Module 1, that is on the introduction to microprocessor 8085, 8086. Here, for both the microprocessor, you have to study basically almost the whole paper, that is their architecture, pin details, instruction set, programming, then addressing mode, memory interfacing, IO interfacing, DMA concept, serial parallel data transfer, all these for 8085 as well as for 8086. Our next module, it's on the peripheral interfacing. Here you have to study several peripheral IC like 8255, 8253, then interfacing of ADC with the processor, arithmetic processor. These are called the supporting IC chip, because you know the microprocessor, or basically if you consider just you are familiar with the term processor, which processes data, and it's actually the heart of a computer. So microprocessor can also be used as the processing unit or computing unit for a processor, for a computer. So its main function, process data. And these peripherals or supporting IC chips used to enhance the capability of the processor. It is to help the processor for processing any particular specified task. Then the next module, that is module 3, it's on coprocessor and microcontroller. Here you study some coprocessors and advanced processors like 80826, 80486, Pentium processor. These are actually advanced version of 8086 microprocessor. And here you have to study this virtual memory, cache memory concept, because this advanced coprocessor has those, they include those features, the virtual memory or cache memory. These type of features are available. So you have to study mainly these 3 processors for these to develop the concept of the virtual memory, cache memory, then the other features of the advanced architecture processor. And then the microcontroller 8051, it's here again you have to study all these like pin description, architecture, then instructions, interfacing, etc. And finally, the 4th module, it is on the advanced microcontroller. Here we'll study the RISC and CISC processor, ARM processor or ARM microcontroller, and some interfacing circuit using ARM. So it's the whole syllabus of microprocessor and microcontroller. So if we want to list down the IC chips that you have to study in this module, these are actually first 8085, 8086. This is a normal microprocessor. Then 8255, 8253, peripherals, then ADC, interfacing. Third, you have to study the 80826, 80, sorry, 80286, 80486, and the Pentium, it's actually 80586. This is the IC number. This type of advanced microprocessors. Then 8051, microcontroller, and finally RISC, CISC, and ARM microcontroller.
ম্যাম মাইক্রোকন্ট্রোলার প্রোগ্রামও করতে হবে আমাদের?
হ্যাঁ, আমি জাস্ট নেক্সট এটাই বলছিলাম। Now in your lab 8085 and 8051, these two are included. So in the lab you have to write programs for 8085, that is using the instruction set of 8085, and then using 8051. These two ICs are included in your lab syllabus. Obviously, some peripherals interfacing is also there, which is mainly on 8255. Okay, so ফার্স্ট ক্লাসেই অনেক কিছু এতগুলো আইসি এই সমস্ত কিছু বলেছি, জাস্ট তোমাদেরকে এটা যাতে তোমরা বুঝতে পারো, সেটা হচ্ছে সিলেবাস কিন্তু হিউজ সিলেবাস। So and from the first day attentively ক্লাসগুলো পড়ো, বা ক্লাসের পড়া যদি শোনার ইচ্ছা না থাকে অন্য কোনো ওয়েতেও প্রিপারেশনটা করে নিও, বিকজ ফার্স্ট থিং ল্যাবেতে 8085 দিয়ে স্টার্ট হবে, and in the lab also you have to do programming using 8085. So for these the architecture and the other parts, that is fundamental concepts, are also required, as well as the instructions. And these whole syllabus, for the whole syllabus, as here 8085 is included, but if we consider the recent era, 8085 microprocessor is actually obsolete. Nowadays we don't use these 8085. Still it is included in the syllabus because to understand the fundamental concept for microprocessor, it's required to know the 8085, or actually the 8085 architecture is easy, and it's you can easily understand it, based on which you can also acquire knowledge about other processors and controllers. Even 8051 microcontrollers architecture is based on 8085. That is why it is still there in syllabus. So now let's start with discussion on this first module. So in general, if you consider a microprocessor, it plays a significant role in the everyday functioning of our society. It can be viewed as a programmable logic device that can be used to control process or to turn on off the devices. That is basically to control and supervise the processes. Or we can consider the microprocessor. It can be viewed as a data processing unit or computing unit of a computer. It can be viewed as a data processing unit or computing unit of a computer or it can be used as a programmable logic device to control processes. So based on this functioning of the microprocessor, we can define a microprocessor in this way. A microprocessor is a multi-purpose programmable clock driven and register based electronic device. Is a multi-purpose programmable clock driven register based electronic device that reads binary instruction reads binary instructions from a storage device called memory. Accepts binary data as input and processes data according to given instructions and provides results as output. So these are the through these we can define a microprocessor. It's a multi-purpose, clock-driven, programmable, register-based electronic device that can read binary instruction from the storage device, accepts binary data as input, and processes those data according to the given instructions, and finally provides results as output. All basic microprocessors work using von Neumann architecture. Basic microprocessors follow the von Neumann architecture. What is this von Neumann architecture? In von Neumann architecture, the processor fetches instruction from the memory, decodes it, and generates appropriate control signals, and finally executes it. And all these steps are executed in sequence. So let me note down these steps in the von Neumann architecture. The steps are: first one, processor first step is the instruction fetch. Second step, decode. Third step, appropriate control signal, and execute. So basically main steps are fetch, decode and execute. And these steps are executed in sequence. This is very important for von Neumann architecture. That is, no parallel execution is possible here. Always the execution in serial manner or in sequential form. Now, the basic microprocessor, also these 8085 microprocessor, follows this von Neumann architecture. It fetches the instruction from memory, then decode it to know the type of the instruction, then it generates the appropriate control signals and processes the data. Using the data, finally it executes the instruction. Now,
মেশিনটা স্লো করে দেবে ম্যাম।
sorry,
মেশিনটা স্লো করে দেবে, যেটা সিকোয়েন্সিয়ালি হয় 1 by 1।
obviously it's a fundamental one, and it's if we compare it with the modern processor 8085, obviously a slow processor.
অ্যাকশন হয় না, কোনো প্রসেসর কোনো অ্যাপ্লিকেশন নেই,
Sorry,
কোনো প্যারালাল অ্যাকশনের আর্কিটেকচার নেই কোনো।
obviously when we'll study 8086, it follows the Harvard architecture where a parallel processing is supported, but we'll discuss later. First, let's start with the basic one, which is the von Neumann architecture.
Okay, ma'am.
Now, let us design a typical programmable machine. A typical programmable machine can be viewed with 4 components. This block represents the microprocessor. Then here, first block, suppose the memory unit, then its input, and this the output block. So this typical programmable work together and interact with each other to perform a given task. So we can say that they comprise a system because they work together and interact with each other. Now, the physical component of these systems are called hardware. the physical components called hardware and a set of instructions written to perform a given task is called program, and a group of programs is called software. Here, using these four physical components or hardware, we can design this system now to process any given task. We have to give this input through a program. A program is nothing but a set of instructions. It's a set of instructions and a group of programs called software. Okay. Now, before the start of execution, the complete program, the whole program must be stored in the memory, that is in the consecutive locations of the memory. And when the whole program is available in the memory, then the execution can be started with these steps, that is fetch, code, execute. And here the instructions we executed in similar steps, that is these steps should be repeated for all the instructions until the execution is terminated by hardware software. That is in the software program. At the end of the program, you can write an instruction which will end the execution, or by hardware means you can terminate the program.
And why it is bidirectional between?
Sorry?
Why it's bidirectional in the microprocessor and the memory?
Yeah, the memory is bidirectional because the processor can read data from memory as well as it can write data into the memory. That is where the arrow is bidirectional. But for input device, the processor reads data from input device, so the direction is from input device to processor, and it can write data into the output device. That is where the arrow is from microprocessor to output device. Okay.
Okay.
Now, for the execution of program or the instructions inside the program, the data may require. This data can be stored into the memory, that is may be available from the memory, or these data can be read from the input port, that is from this input port, and the result of the program can be stored in the memory or can be transferred out through this output port. L194. Now, the microprocessor, it operates in binary digits or bit That is, it can process the information which is available in the bit form, that is in as a stream of 0 and 1s. And each microprocessor can be recognized by the number of bits it can process at a time. Just for example, let me first. Each microprocessor processes a group of bits at a time. This is called the word called the word length of the microprocessor. So there is a group of bits. This is called word. Word or word length, same almost. So the processor can process a set of bits or a group of bits at a time. And based on this, the word length of the processor can be identified. For example, if a processor can process 8-bit
ম্যাম একজন এসেপ্ট করতে বলছে।
সরি
একজন ঢুকতে পারছে না ক্লাসে একজন।
ওকে আমি অ্যালাউ করলাম, ঠিক আছে আমি আবার করে দিয়েছি।
থ্যাংক ইউ ম্যাম।
So a processor with 8-bit word length is called eight-bit microprocessor. Similarly, a processor with 32-bit word length is called a 32-bit microprocessor, and so on. So based on the word length, we can define the microprocessor. And word length means the number of bits the processor can process at a time, that is in a single clock period. Now, it is the time 10:40. Okay. Let us now discuss the memory. We already discussed is one. memory, just you can view the memory as a page of a notebook, where the number of lines in the notebook is fixed and the number of word in a particular line is also fixed. So the memory, it's like a page of a notebook with space for fixed number of binary numbers on each line.
मैम
So if you consider it
122
as
को एंट्री दे दीजिए
हाँ?
122 को एंट्री दे दीजिए क्लास में
I have already allowed. So if you consider it as a page, so these are lines, and you can there may be several words in particular line, but for a memory, these number of the word in a particular line should be fixed. In the memory, these pages are generally made of semiconductor material, and in each line, we normally consider that each line corresponds to an 8-bit register. So it can store 8-bit binary information, and a number of these registers are arranged in sequence, then it is called the memory.
And each line will consist 8-bit length, or the whole memory contains.
So let us consider this is a memory. So all these are known as this. So each line corresponds to a register. A register means a group of flip-flops, per flip-flop can hold 1-bit information. So normally we can say that the registers, a memory can be made of 8-bit registers, but if we consider a typical memory chip, then normally it comes with 8-bit registers. So memory is a group of 8-bit registers, and so each register comprises a particular memory location, and in a as the register can hold 8-bit information, it means in a particular location in the memory, you can store 8-bit information. This is the typical structure, but you can have a memory which can store only 4-bit information in a particular location, or only 1-bit information. Those all are possible, but 8 bits, it's a typical concept. Typically, a location can store 8-bit information. So again, we can write it in this way. Memory is a group of registers. And remember that these registers are always grouped in power of 2. Just for example, if you consider a group of 512 mm, yeah, another value, say 2048 registers with 8 bits each, then we can call it as 2K byte of 2K bytes of memory. This is because you see here 2048. If you convert it in power of 2, it's 2 to the power. What is the value? 2048, 2 to the power 11. You can remember in this way 1024. That is actually approximated as 1K, and 1024, it's equals to 2 to the power 10. So 2048, that you can write it as 1024 into 2. So it is 2 to the power 10 into 2 to the power 1, that is 2 to the power 11. So as 1024 1K, so we can write it as 2K, and bytes, it's because each register can contain 8 bits equals to 1 byte. That is why there's a group of 2048 registers with 8 bits each can be called as 2K bytes of memory. Is it clear?
Yes, ma'am.
Yes, ma'am.
Remember that, because semester এন্ডে যখন ল্যাবের এক্সামে এই টাইপের কোশ্চেন করা হয় তখনই অনেক সময় আনসার পাওয়া যায় না, though it's very simple thing.
And that means each register processes 8 bit of word length.
Yeah, no, typically the memory chip comes with these 8-bit registers, because we can easily consider it as 8-bit means 1 byte, and then depending on the number of registers you can find out the total size. It is generally write it in this way: 2048 into 8 bits, so which is equals to 2K byte.
And if it is 32-bit processor, then what, how it will process the memory in the register?
For 32-bit processor, it will access 4 memory locations at a time.
Okay.
Can
Ma'am,
you-
means in each memory location there will be only one 8-bit register.
Yes.
That means it will process parallelly.
Process parallelly.
For
নর্মালি আমাদের মানে 1 বিট প্রসেসর এরকম তো হয় না, একদম ফার্স্ট যেটা ছিল দ্যাট ওয়াজ 4 বিট প্রসেসর, দেন 8 বিট 8085 it's very fundamental one, so it can process 8 bit data at a time, that is parallelly 8 bit at a time.
Okay.
And for our other higher level processors, that is when we talk about this 64 bit processor, normally our laptops and other electronic components now we get it as 64 bit processor. It means it can process 64 bit data at a time. So if you interface a memory which can store only 8 bit data at a particular location, so at that time it will during the processing it will access total 8 locations at a time.
Okay.
Okay, then just tell an example of input device.
Keyboard,
Keyboard.
mouse.
Keyboard.
So actually the user can enter instructions and data into the memory through the input device. So input device, mouse, switch. These are example of input devices. And output devices,
Monitor, printer.
Monitor, printer, speaker.
monitor, printer. LEDs can be used as the output device. Okay, so input device to read, the processor reads data from input device, and the result which is generated by the processor can be displayed through the output device. Okay. So now
ম্যাম একটা কোশ্চেন আছে
hmm,
ম্যাম এমন কোন ডিভাইস আছে যেখানে ইনপুট ডিভাইস আর আউটপুট ডিভাইস মানে দুই আছে মানে দুটি প্রপার্টি আছে
obviously a graphic display, a touch screen of your mobile phone or laptop. That is why in the normally input output device we write it as IO device. So now if we design microprocessor as a CPU, it will contain arithmetic logic unit, control unit, so this is actually the CPU. Now it can communicate with good output. And with the memory. Here, this communication is actually through the control unit. So we can draw in this way. So in this way, we can illustrate the microprocessor as a CPU. Here, the CPU consists of two main units, arithmetic logic unit and the control unit. The arithmetic logic unit performs various arithmetic and logical operations. And the control unit supervises the function of all the blocks in this diagram. That is, it controls the operation, or it generates the required control signals for the processing of the arithmetic logic unit. Also, it generates the required control signals to read data from input and or memory, and also to write any data to the output device or the memory. So control unit supervises the functionalities of all the units which are present in the block diagram of microprocessor. These are main units of a microprocessor. Other co-units are also there. Sub-unit, sub-parts. We'll discuss in details later for a particular type of processor. Now, actually in time is over, so microcontroller part first we'll discuss this one, then start discussion on 8085 in our next class. Do you have any question?
Ma'am, arithmetic logic unit and control unit are two separate microprocessors, or like?
No. These are part of the processor.
Okay. Okay.
Actually, we can say it as microprocessing unit. Just a minute.